Hi everybody, Sherry Ann here and welcome to my chemistry hub. So today we'll be doing a CSEC past paper question, and this is from this year, January, right? Alright, so let's get into it. The first question is, the concentration of a solution of sodium hydroxide in grams per dm cube was determined via the method of thermometric titration with a strong acid. The following procedure was used. First, they transferred 25 cm cube of sodium hydroxide solution, unknown concentration, into a styrofoam cup, took the initial reading of the solution, initial temperature reading that is. Then they added 5 cm cube of sulfuric acid, 0.1 molar from the burette, into the cup, immediately stir the mixture and record its temperature. Then they repeat the procedure, adding 5 cm cube aliquots of sulfuric acid until they added 30 cm cube in total, right? Now it says figure 1 shows the thermometer readings of the acid-base reactions after the additions of 5 cm cube, 15 cm cube, and 25 cm cube of sulfuric acid. So I have our thermometer reading here, thermometer reading. And of course, question A says using the thermometer readings in figure 1 on page 5, complete table 1 by recording the temperatures for the additions of 5, 15, and 25 cm cube of sulfuric acid. Alright, so let's take our readings. My drawing here. Alright, so at 5 cm cube, the temperature reading is 27, so this would be 0.1 each, so 27.1, 2, 3, 4, 5, right there, 27.5. At 15 cm cube, it's at 33.1, 2, 3, 4, so 33.4 degrees Celsius. And at 25 cm cube, it's 28.1, 2, 3, 4, 5, 6, 7, 8, 9. 28.9 degrees Celsius. All right, so let's just put that in our table. So 5 is 27.5 degrees Celsius, 15, 33.5, and 25 is 28.9. Easy 3 marks. So BI says, using the axes provided in figure 2 on page 7, plot the graph of temperature against volume of acid added. And on that graph, we're going to draw 2 lines of best fit to the points on the graph, one where the temperature is increasing and the other where the temperature is decreasing. All right, graphs. All right, so let's plot our graph. At 0, we'll have 25 right here. At 5, we'll have 27.5. 5 would be about right here. 4, halfway through, right there. 5 will have 27.5. So that's 27.5 would be 2, 4. 5 would be right there. At 10, we'll have 30.5. 30. 2, 4, 5. At 15, which would be right about here, we'll have 33.5. 33.2, 4, 4, 5 right here. And at 20, 32.5. 2, 5. And at 25, which will be about right here, 25 we have 28.9. 28 is right here. 28.246. 8, 9 will be about here. right below that line. And at 30, we have 26. 26, 19. All right. So then it says to draw a line of best fit between where the temperature is increasing and also where the temperature is decreasing. So of course you use your ruler to do this. I'm going to try my best to do it freehand. Not going so great at first. So that's where the temperature is decreasing. Let's use another colorful. Increasing. Let's use another colorful. The temperature is decreasing. Da, 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 da. Let's see how best I can draw this. Nope, that's not the line. That's it. Let's try and do that a little bit better. See if we can actually go through all of them. All right, I think that's the best I can do, but of course you use your ruler to get a more accurate reading, not your reader. All right, so go back to other questions. So we plotted our graphs. Of course, you'll have your title. Do we have a title on this one? Did they put a title first? No, they did not. Let's see. Graph of temperature, which is the title of your y-axis, versus volume of sulfuric acid in centimeters cubed. And of course, you underline it. All right. Then the next question says, on your graph, show the endpoint of the reaction according the corresponding volume below. So your endpoint would be where the two lines of best fit intersect. That would be your highest point. And then that would correspond to your equivalent volume. Let's see. So it'll be right here. Let's see how best we can do that. Trying to go along one specific line so it can be as straight as possible. I think I'm messing up, but this will be about your equivalence. Volume equivalent endpoint. Endpoint. Endpoint is usually the same as the equivalence point in most cases. Sometimes you can have a difference called a titration error, the difference between minor difference sometimes between the endpoints and the equivalence points. But this would be your equivalence volume, and that looks like about 17 centimeter cube. Yeah. 17 centimeter cube. Let's write that in. Endpoint of the reaction, 17 centimeters cube. Then the next question says C, distinguish between a strong acid and a weak acid. So essentially a strong acid is one that dissociates, strong acid, ionizes completely in solution. Acid dissociates or ionizes completely in solution. An example of this, of course, is like HCl, or the one that we used in the experiment, H2SO4, or even nitric acid. So all inorganic acids, those are strong acids. However, weak acids partially dissociate completely. Let's put that in, completely, for your strong acid. And then weak acid partially dissociates or ionizes. Oh, we have completely here already, of course. Let me see that. Partially dissociates. Try that again. So the next question says, distinguish between a strong acid and a weak acid. So essentially a strong acid dissociates or ionizes completely when in solution. Dissociates or ionizes completely when in solution. An example of a strong acid is like HCl or sulfuric acid, H2SO4, or nitric acid. Most inorganic acids, these are strong acids. And then weak acids dissociate or ionizes partially when in solution. So with a strong acid, you have with strong acids you have a high concentration of H plus in solution. However, weak acids, you have a lower concentration of H plus ions in solution. And of course, your weak acids are like your carboxylic acids, your organic acids like ethanoic acid or methanoic acid, any organic acid, so your organic acids. Butanoic acid. So those would be your weak acids. All right, so let's go on to the next question. So we plotted our graph. D says write a balanced equation for the reaction between sodium hydroxide and sulfuric acid. That's a simple 2 marks. So 4 gives you your salt, sodium sulfate, and water. Of course, you have to remember our state symbols. Aqueous and liquid. And of course, remember our coefficients to for balance. So you have one here, one sodium, two sodium over there. We have how many? Six oxygens. Not six. Yeah, six oxygen on this side, and one oxygen on this side. Let's put a two here. We have two and six, two and four, two and four, six, two and four, six oxygen, four hydrogens, one sulfur, and of course our two sodium, where we are balanced. All right. Moving on to the next questions, calculate the number of moles of sulfuric used in the reaction. Now, to calculate the number of moles, we have two ways, right? Sometimes when persons see moles, we get a little bit flustered. So I usually use my triangle here to help me. If you look at our page, we have some tips that we recorded in terms of how to handle moles questions. Anyway, so this is one of them. So, and if you need to find, so this is concentration, this is volume, and this is moles. That's one way to find it. So if you want to find volume, it essentially would be number of moles divided by concentration. If you need to find moles, it would be concentration times volume, right? Let's look at another one. To find moles. So if we're given a mass, and you know the molar mass, you can find moles, which is of course in. And molar mass, of course, is found from your periodic table. So the molar mass of sodium is 23 grams per mole. Molar mass of chlorine is 35.5 grams per mole. Of course, the molar mass of sodium chloride would be 23 plus 35.5. So yes, that's your molar mass. So and it's the same principle as the first one. So if you're given a mass and you're asked to find the number of moles, it will be that given mass divided by molar mass, right? If you're given moles and you're asked to find the given mass, then that would be moles multiplied by the molar mass, right? That's why you use your triangle. So essentially to find one, you usually, I tell my students to use their thumb and cover up the one that they're trying to find. So if you're trying to find given mass, you use your thumb and cover up that, cover up that in the pyramid here, the triangle, and then that will give you, or that will show you that to find given mass, you multiply moles by your molar mass, right? All right, so let's look at E. Calculate the number of moles of sulfuric used in the reaction. Always ask, don't get flustered when you see a moles question. Look at what you're given. Well, when you're doing any calculation, look at what you're given, how we can use that to solve the question. But especially when it comes down to moles, look at what you're given and see how best you can use it to find what you are asked. So let's look at, before we look at what we're given, what are we looking for? So to calculate the number of moles of sulfuric acid, we're either looking for concentration and volume, or we're looking for a given mass, and of course the molar mass of sulfuric acid. So let's look at the question. In the question, they gave us concentration of sulfuric acid as 0.1 molar, right? And we also have the endpoint reaction, the volume of sulfuric acid used, so that we can easily find moles. Can easily find number of moles because concentration, we're given that, we're given volume, we simply multiply concentration by volume to give us number of moles. Number of moles is equal to the concentration of 0.1 molar multiplied by 17 cm cubed. Now remember, this molar is moles per dm cube, right? I have to work in the same units. So essentially, we have to change the 17 to dm cube. So it'll be 0.1 molar multiplied by 0.017 for 1,000, 1, 2, 3, dm cube. Right? So multiplied by 0.1 would be 0.0017 moles. Sulfuric acid, of course. Then they ask us to calculate the number of moles of sodium hydroxide in 25 cm cube of the solution. So let's look at what we have of sodium hydroxide, right? What did they give us? Remember, to find moles, you're looking for either concentration and volume or mass and molar mass. So for the sodium hydroxide, we are given, let's look at our question. That's the volume, unknown concentration. We got the volume here. We don't know the concentration. What else? Were we given a mass? No, we were not given a mass. So let's go back to our question. When you see when you see a question like this, most times you have to refer, or what you do, not most times, what you do is you refer to your balanced equation to find the mole ratio. So we do have a mole, number of moles, but that's for the sulfuric acid. We have volume for the NaOH, which is 25 cm cube, right? But how would we find moles? We don't have concentration. We're not given a mass, and we can find a molar mass, but if we're not given a mass, how can we find moles? Now, what you do is you refer to your balanced equation. And this goes back to using what you do have to find what you don't have. You do have moles, but that's for sulfuric acid. How can we relate the number of moles of sulfuric acid to the number of moles of sodium hydroxide? So essentially, you look at your balance equation and you determine the mole ratio between sodium hydroxide and sulfuric acid. We can see that there's a 2-to-1 mole ratio. So 2 moles, so write a statement so that the examiner knows what you're doing. So based on that balance equation, based on your balance equation, 2 moles of sodium hydroxide is equal to 1 mole sulfuric acid. That's your mole ratio, right? Stoichiometry. So if 2 moles sodium hydroxide is equal to 1 mole sulfuric acid, how many moles of sodium hydroxide is equal to 0.0017 moles? That will be X moles NaOH is equal to 0.0017 moles sulfuric acid. And of course, we do our cross multiplication. So X is essentially equal to 0.0017 times 2 That is 0.0035, right? Simple. Calculate the concentration of sodium hydroxide in moles per dm cube. Again, what are we looking for? We're looking for moles and volume because that's the only triangle with concentration, right? Looking for number of moles. We're looking for moles and volume, right? So we have our moles, we just calculated it, and we have our volume. So concentration is equal to number of moles divided by volume. So it will be 0.0035 moles divided by 25 cm cube. And of course, you need to change this to 0.025 dm cube. Because they asked us to calculate in moles per dm cube. What is our answer there? So 0.14 moles per dm cube, or 0.14 molar. All right. Calculate the concentration of sodium hydroxide in grams per dm cube. So that's your mass concentration. Given the molar mass of sodium hydroxide is 40 grams per mole. So your mass concentration, so we already calculated our molar concentration, right? Molar concentration was 0.14 grams moles per dm cube. I'm going to show you something with your units. And to get our mass concentration, we simply multiply that by our molar mass here. Molar mass is 40 grams per mole. Look at our units. So this will cancel, right? This will cancel and this will cancel. So grams per dm cube. So yes, that's to show you how you can use your units to guide you as to if you're on your right track or if it's supposed to be the concentration divided by RMM, or concentration times RMM being your molar mass. You can use your units as a guide. So you are indeed on the right track because then the units would be grams per dm cube, right? So it'd be 40 times 0.14, which would be 5.6 grams per dm cube, which is your mass concentration. State whether the reaction that took place in the styrofoam cup was exothermic or endothermic. Now, of course, we know that neutralization reaction or acid-base reactions, these are exothermic reactions. So the reaction that took place is exothermic. Why is it exothermic? Is an exothermic reaction because there's an increase in temperature, as we saw, as there was an increase in temperature. Increasing temperature, which is characteristic of endothermic reaction, right? So the reaction is an exothermic reaction because there's an increase in temperature as heat is being released. Heat is being released. Which is a characteristic of exothermic reactions. State one safety precaution which should have been taken during the experiment. You wear gloves. wearing of PPE, your personal protection equipment, your PPE, right? So such example, your safety gloves, your safety glasses, spell that right. Because the exothermic reaction, some of them can get really hot, it can burn your skin if it catches your skin. And yes, that's question one.